everyone. Hope all of you are doing well. In the last videos, we were discussing the previous question papers from the chapter Electricity of Grade 10. We are discussing almost 10 years of question papers in chapter-wise. If you have not watched till part 5, please watch it before going ahead with part 6. Are you ready to start with the first question? Okay, the question is asked in 2015. And the question is, what is meant by electric resistance of a conductor? How is it determined? Name and define its SI unit. Now we have 3 questions in it, right? So we can answer one by one. What was the first question? What is electric resistance? So from the word itself we can understand that resistance means that will resist the flow of charge through it. Okay, so how we can define it? Electrical resistance is the property of a conductor to resist the flow of charge through it. Okay. The second question is, how is it determined? How we can calculate the resistance? Yes, from Ohm's law we have R is equal to V by I. So that we can find the resistance by using V by I. Okay, and what is the SI unit of resistance? That is Ohm. Okay, now we have to name and define its SI unit. So we know that the SI unit is Ohm, and how we can define it? Suppose we are putting that V is equal to 1 volt and I is equal to 1 ampere, then what will be the resistance? Then we can define it as, if the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance of the conductor is 1 ohm. Okay, so that we have to put V is equal to 1 volt and I is equal to 1 ampere. So 1 ohm is equal to 1 volt by 1 ampere. Is it clear? Can we move to the next question? Okay. The question is asked in 2015 and the question is, the resistance of a wire of 0.01 centimeter radius is 10 ohm. If the resistivity of the material of the wire is 50 into 10 raised to minus 8 ohm meter, find the length of the wire. Here what are the given quantities? Yes, the resistance is given as 10 ohm. Then the resistivity is 50 into 10 raised to minus 8 ohm meter. The radius is given as 0.01 centimeter. So that centimeter we can convert into meters. So how we will do? That is 0.01 into 10 raised to minus 2 meters. Okay. Now how we can find the length? So the equation connecting resistance, resistivity, then length, area. Which is the equation? Yes, that is R is equal to rho into L by A. When we rearrange the equation, we will get the length, that is L is equal to R into A by rho. But the problem is that here we don't have area. How we can find the area of the wire, right? So that area is equal to pi r square. So that we can calculate first. So how we will get? Pi is 22 by 7 into R is given here, right? So that is 0.01 into 10 raised to minus 2 meters. So that R square is that much whole square. So that value is found to be 3.143 into 10 raised to minus 8 meters square. Now we have area. Then rho is already given. Then R is also there. So can we calculate length? Okay. Now we can substitute the values. So what we will get? L is equal to RA by rho, right? So that will be equal to 10 into 3.143 into 10 raised to minus 8 divided by rho, that is 50 into 10 raised to minus 8. So the value we are getting as 0.6286 meter or 62.86 centimeter. Is it clear? Can we move to the next question? Okay, the question is asked in the year 2016 and 2015. The question is, VI graph for a conductor is as shown in the figure. The diagram is given here. And the question is, what do you infer from this graph? The second one, state the law expressed here. The third question, name the physical quantity represented by the slope of this graph and state its SI unit. Can we answer the questions? Okay, the first question is, what do you infer from this graph? So what we can understand from the graph is showing a straight line. Okay, the current is taken along x-axis and potential difference along y-axis. Here we can see a straight line graph which is passing through the origin, isn't it? And as the current increases, what happens to the potential difference? Yes, that also increases. What does it mean? That means the potential difference is directly proportional to current. That means V is proportional to I. Now the second question is, state the law expressed here. So from the graph, what we can understand, the shape of the graph is a straight line that passing through the origin. So which obeys Ohm's law, right? So that is why we can state Ohm's law here. What is Ohm's law? The potential difference across the ends of a given metallic conductor is directly proportional to the current flowing through it. Okay, provided its temperature remains the same. So that is the second answer. Now we can move to the third question. We have to name the physical quantity represented by the slope of this graph and state its SI unit. What will be the slope of this graph? What is slope? That is y by x, right? If you are taking y by x, what we will get? That will be potential difference divided by current, that is V by I. What is V by I? Yes, that is resistance. So the physical quantity is resistance. And what is its SI unit? That is ohm. Okay. Is it clear? Can we move to the next question? Yes, the question is asked in 2015 and 2014. Okay. The question is, calculate the resistivity of the material of a wire of length 1 meter, radius 0.01 centimeter and of resistance 20 ohms. Here what are the quantities given? Yes, the length of the wire, that is 1 meter, then radius, that is 0.01 centimeter, and resistance, that is 20 ohms. What we have to calculate? Yes, the resistivity of the material we have to calculate. So which equation is connecting all these quantities? Yes, we have R is equal to rho into L by A, right? So that we can directly calculate the value. Is there any conversion of units? Yes, here the length is in meter and radius in centimeter. So it is better to convert the radius into meter, that is the SI unit. Okay, so how we can convert this 0.01 centimeter into meters? Yes, that is 0.01 by 100 meters. Okay, now how we can find rho? We can cross multiply, right? So rho will be equal to RA by L, and we don't have the value of area. So how we can calculate area? That is equal to pi r square, right? Here we have area is equal to pi r square, that will be equal to 22 by 7, that is pi into 10 raised to minus 8 meter square. So that directly we can write there, and here we have area A is equal to pi r square, that will be equal to 22 by 7 into 10 raised to minus 8 meter square. Okay, and rho is RA by L. So we can substitute the values of RA and L. So what we will get? That will be equal to 20 into area is 22 by 7 into 10 raised to minus 8 divided by 1. So that will be equal to 62.86 into 10 raised to minus 8 ohm meter. So that is the resistivity of the material. The next question is asked in 2015. Here draw a VI graph based on the following data. The data is given as voltage in volts, that is 1, 2, 3, 4, 5, and the current in amperes, that is 0.25, 0.50, 0.75, 1, 1.25. Now what would be the value of V by I ratio when the potential difference across the resistor is 3.6 volt? So that is the question. Here we have to draw the VI graph. The values are given here, potential difference and current is there. So how we can draw the graph? We have to take current along x-axis and potential difference along y-axis, right? So how we have to select a scale. So according to the values we can select any scale. Here we have 1 to 5 the values, right? So it is better to select 0, 1, 2, 3, 4, 5, 6 like that. Okay, so that will be along y-axis. And what about x-axis? In x-axis we have the values of 0.25, 0.50, 0.25 difference is there between all the readings, right? So which will be appropriate scale? Here it is better to take 0, 0.25, 0.5, 0.75 like that. Okay, it is not compulsory to select the same scale. We can make it 0.5, 1, 1.5 also like that. Okay, so that is up to you. Now we have to mark. The points as shown in the diagram. Here we have the value of V as 1 and corresponding current is 0.25. So how we will mark? Here we can see that along y-axis we have 1, along with that we can see 0.25. So that point is marked as the first point, and the second one is 2 and 0.50. So for 2 corresponding to that we have 0.5. So like that we can mark the points and join it to get a graph. Okay. Here we have one more question, that is, what will be the value of V by I when the potential difference across the resistor is 3.6 volt? Yes, here for 3.6 volt we are getting the value of current as 0.9 ampere. So what will be the value of V by I? So that will be 3.6 by 0.9. So that is 4 ohm. That is the value of resistance. Hope it is clear to you. Can we conclude now? If you like this video, please like, share and subscribe. Thanks for watching.